So the homework was two parts. It was, hey, I have this game of asteroids and I want to slow down the rate at which the projectiles fire. So I wanted you to add a cooldown to the projectiles so that you couldn't fire them so fast. And then the second part was I wanted you to add the concept of a multi-shot bound to a different key that you can click. I didn't really care what key you pressed. I said control, I think, but we're going to go over those two things and explain like how to use loops to your advantage as well to accomplish that. So the main thing is that let's get the firing rate in order. So right now, the bullets are basically firing as fast as my game is ticking. So every time my ship gets a call to the update function, if I'm pressing the spacebar, it'll create a bullet. And the behavior here is that on the player here, so here's my player, here's the update function for the player, and right here, if the key is pressed for space, then I'm considered firing. And as long as this condition is true, I'm just going to create a bullet. But this function that I'm in gets called every frame, which means that my bullets are firing at 60 times a second, or probably more than that depending on how fast my game is running. And the problem is that I want to limit that. I don't want it to fire at 60 times a second. I want to add an interval between each shot so that I have to wait at least a fifth of a second. And the key is that I want to fire 5 bullets every second. So the way that you manage that is by taking this condition here and adding more behavior to not just firing a bullet if you have that spacebar held down, but also checking that you have this concept of a cooldown and that your current cooldown is low enough that you can actually fire a bullet. So if I added a condition onto here that says, hey, my cooldown has to be some number or less, then I can control this value. So if I use this DT that's passed in here in the player update function, I can take that and I can count how much time has passed since the last time I've actually really fired a bullet. So here's what we're going to do. I'm going to go to my player class and I'm going to add the concept of a cooldown. And this cooldown I'm going to treat saying, hey, as long as this number is greater than 0, that means my weapon is on cooldown. That means that I cannot fire another weapon. And what I'm going to do is inside the constructor here, I'm going to set this value to 0 by default, which means if this number is on cooldown, it's going to be greater than 0. So by default, I'm not going to be on cooldown for my weapon. And then here inside my update function, all I'm going to do is I'm going to subtract dt from it. And this dt subtraction means that I'm always subtracting one value from this every second. So every second that this thing passed, dt amounts to the number 1. This thing is going to be really small at first, so it's actually going to count down to negative, but that's okay. We don't really care about that. And the key is that I want to add a condition here that says if the cooldown is less than or equal to 0, that's the only time I can actually fire a bullet. Okay? And then every time I fire a bullet, that's when I want to reset this cooldown. So if I actually get inside of here, what I can do is set the cooldown to be something like this. If you wanted to, if we want to fire 5 bullets every second, you could do this math here, and instead of doing 0.2, it's the same thing. The number of bullets I fire per second is this value right here. So what's going to happen is that I'm going to fire a bullet. It's going to reset the cooldown to be 1 over 5, which is 0.2. Going to create the bullet, and then the next time I call this update function, this cooldown is still going to be greater than 0.2, so it's not going to fire another bullet. It's only going to fire a bullet as long as this value is less than or equal to 0. So now I'm firing my bullets, and that value is controlled by that number that I have here. If I wanted to change it so I fired 1 bullet every second, all I have to do is change this value to be 1. And now I'm not allowed to fire a bullet more often than once every second. That's my cooldown. I cannot fire a bullet any faster than that. Okay? And if I want my cooldown to be something kind of small, this will fire, I think, 20 bullets every second. You can still control that. However, now it's a consistent amount every time. Any questions on that? Okay, so the next thing I wanted to do was add the concept of a multiple shot. That is a button that you can press that lets you fire a bullet in 3 different directions every time you fire. And the key here is that you need to not only spawn 1 bullet in that case, you actually need to spawn 3 bullets. And but first we need to actually distinguish whether we're firing a single shot or a multiple shot. Right now my shots are distinguished by here, whether the key is pressed for whether I'm firing or not. And instead what I want to do is I want to bind left control to say that I'm going to fire a multiple shot. And so in that case here, the first thing is I just want to say, hey, left control is also capable of firing a shot. So if I add this condition here, if I add an OR and combine that with the left control key, now when I'm pressing left control, it also lets me fire bullets. So I'm pressing left control right now, and this is me pressing spacebar. It looks identical. But now at least I can fire using either one. And by firing in either one, I can also detect which one of these things I've pressed. So why don't we start with having, hey, if I'm using left control, let's make it so that it looks a little bit different. I just want it to fire a little bit differently. Maybe I increase the cooldown if I fired using left control. So in this case here, I have this concept that I have left control in space. This cooldown is getting set to 0.2, but it's always getting set to 0.2. What I can do instead is if I have my left control pressed, that means that I want to fire my multi-shot. That means that I can make my cooldown 1 second. Otherwise, that must mean my weapon that I have is my normal shot. So by adding this if condition inside my cooldown after I fired a bullet, I can say like, oh, I must be doing a multi-shot here. Okay. So by testing this, pressing spacebar gives me this high fire rate, pressing left control gives me this. And I can't press fire again until I've exhausted the cooldown for my normal shot. So I'm firing like essentially a heavy shot, and I can't fire immediately again until that cooldown is released, which is what I want to have. So now what I actually want to do is I want to change what kind of bullets I'm spawning. So I'm going to move this code for bullets into the else condition, and in this condition I'm going to add my special case. For now I'm just going to spawn 1 bullet, but what I can do is I can just change the velocity of this bullet just to see that it's going to spawn a different kind of bullet. So if I press control, it's going to spawn a really slow bullet once every second. It's cool. It's a way to distinguish it from my regular shots. And all I have to do now is I have to spawn 3 of these at different angles. Now the angle here is controlled by this angle variable, which I happen to have gotten from the angle of the player. So I can use this to control the angle of the ship. So let's just start off by saying, okay, I want to spawn 3 bullets. And the 3 bullets are going to be exactly the same except for the angle that they're firing from. So because I know that everything is going to be the same about these 3 bullets except for the angle, my initial inclination is to try to write a loop to make it so that I can create 3 bullets exactly the same and changing one little thing. If I write a loop here to say, hey, loop 3 times, I can spawn my 3 bullets in here. I don't have to write a loop. Like I could do this, right? Make 3 bullets. And I could say, hey, add some amount of angle here to solve this. However, look at these 3 like kind of chunks of code here. The bullet spawning behavior is exactly the same. All the lines of code are exactly the same. The only difference is this little bit right here. And when I look at this, what I'm looking for are things that are common so that I can say, hey, a lot of this code is the same. Why don't I just take this code, take the part that's different, and create a formula that lets me get these numbers by using a loop variable. If I take this code right here, and I take the angle and I add I to it, this angle is going to be increased by the value of I every time through the loop. Now I is going to be 0 to start, so it's not going to add anything the first time through the loop. The second time through the loop, I is going to be 1, so it's going to add 1 degree to this angle. But I don't have to add just 1 degree. I can add a little formula here to say, hey, take the value of I and multiply it by 15. So if I is equal to 0, this whole expression will be 0. But if I is equal to 1, this whole thing is 15. If I is equal to 2, this whole thing is 30. So the angle that my bullets are firing at are controlled by the value of I, which means that I get the same result here, but by writing it 1 time only, like so. So there's one more thing that we need to do, but I'm going to show you what this looks like here. So I'm creating 3 bullets every time I hit control. But see the angle that they're firing? They're slightly off. So one's firing straight ahead, and the other 2 are firing to the right. How do I move this thing so I fire 1 to the left, 1 to the middle, and 1 to the right? Well, the angle here is the angle of my ship, and I'm adding 15 to it every time. If I want to make it so the first bullet is to the left instead, all I have to do is subtract 15 from it, because I know that's the angle that I want to fire these bullets from. So now my first bullet will fire at, this is going to be 0, so it's going to be the angle of the ship minus 15. The second bullet is going to be 15 minus 15, which is going to be, this is going to equal to 0. It's just going to be that. And then the second bullet, or the third bullet, is going to be I times 15, where I is equal to 2, and this is going to be 30 minus 15. This whole expression ends up just being 15, and that's going to be the angle. So now by doing this behavior, I get my nice bullet spread that starts off with 1 in the middle and 1 on the left and right. What if I wanted to do more than just 3 bullets? What if I wanted to do a spread of 5 bullets? Well, I know that I have 5 bullets. I know that my first bullet, I want to start 30 degrees to the left, so I can do that. But the rest of the code remains exactly the same. So here's my spread of 5 bullets. What if I wanted to decrease the angle? Right? What if I wanted to have a 10-degree spread? Well, I just changed that here. And now my spread is going to be a lot tighter. Or even like a 5-degree spread. Right? What if I wanted to have 10 bullets? Right? How much is my angle going to be? Okay. $25. So by writing a loop, you don't have to write this same statement every time. If I wanted to have 30 bullets, I don't need to do this. I just have to write a loop that does it 30 times, right? Okay. Any questions on that? That makes sense? Yeah.
Quick question. Did you want us to have the bullets so at the end of the screen they destroy at the end of the screen, or should they?
Oh, that's right. Yeah, I did want that too.
Okay, I just wanted to make sure.
Let's go over that too. So one thing that I forgot is that, yeah, the bullets, I want to show that you can actually change the behavior so that they don't go off the edge of the screen. Instead, they'll get destroyed if they go off the edge of the screen. In addition, I have this function for applying drag, which I don't want to have for my bullets, which we did in lab. If I don't want to apply drag, I just keep it empty. So in this case here, let's change the behavior so that if the bullets hit the edge of the screen, they'll get destroyed. Because right now they go off the edge and they keep going. And instead, what I want to do is kind of the same behavior that we did for detecting whether you're at the edge of the screen for the normal game object here. So see all this code here that is inside the game object that says, hey, if you're at the edge of the screen, then go ahead and put yourself, teleport to the end. Instead, what we want to do is, for the bullets, if I want to make it so that the bullets themselves get destroyed, inside the bullet update function itself, and only inside this function, I can do some behavior here. I already have code in here to destroy the bullet if it's been alive for 3 seconds. So what I can do is take all this code that was for, hey, I'm off the edge of the screen, and then do something about it. So in this case here, I have 4 conditions for X on the left side, on the right side, and then Y on the top of the screen and on the bottom. And instead of teleporting, all I really have to do is take all this logic and call destroy on each one of these cases. And this way, even though a bullet's going to try to teleport off the edge of the screen, oh, here, what we're going to do is we're going to make sure to put this logic before the update function. This is the key. So the first thing it's going to do is it's going to detect whether it's been alive for too long, and then also detect whether the position is currently off the edge of the screen. Let me make one more thing here. One more piece of behavior I think we need, because yeah, this thing is still not going to work. So the order of operations here are very important. I don't know how many people actually got this, but the way that this code is written here, this position, while we are trying to check to see if it's less than 0 or greater than 0 or greater than the edge of the screen, this logic here will never be true because we only ever move the bullet inside this function here. So there's a couple ways we can do this. One way is that right now we're adjusting the position of the game object before we actually test to see if it's on the edge. What we can do instead is adjust the position of it after we detect if it's on the edge of the screen after we've detected this. And so when you fire the bullet now, the order of operations here is very important. So watch what I did here. So the first thing that game object does is it moves the position of the sprite based on how fast it's moving, and then it detects if it's on the edge of the screen. If we change it so that this thing happens afterwards, what's going to happen is that the position is going to be tested first, and then it's going to move it. But the bullet itself, the first thing it's going to do is detect if it's off the edge of the screen, and then we're going to move the projectile. Yeah. Do you have a question, or are you just ready? There's another way that I kind of want to show you how to do this. And we're going to use object-oriented programming to solve this, because I really don't want to write this if statement more than once. And what I just did for moving the position here is not really what I want to do. So let me show you guys kind of the way that I would. So I didn't expect you guys to do this, but I'm going to show you how to actually use all the stuff that we've been doing to kind of leverage object-oriented programming. So if I make a function here inside GameObject that is like, hey, went off edge of screen, and it doesn't do anything, I'm going to leave it empty by default, but I'm going to make it virtual. And here's what I'm going to do. I'm going to call this function here in every time that I go off the edge of the screen. This is inside the game object, okay? And this function, when it's going to get called anytime a game object goes off the edge of the screen. And then inside the bullet here, what I'm going to do is I'm going to get rid of all my code that I wrote for the if statement here. I'm not going to do any of this. And instead, I'm just going to write this one function that calls destroy. And that's it. And this behavior will give me the exact same mechanics of destroying the bullet when it goes off the edge of the screen. However, I don't need to write any edge screen detection code. Because, again, I already wrote all that code. I wrote that code for the base game object. I already know when I go off the edge of the screen, and I teleport them for the player. But however, for bullets themselves, what I want to have happen is when it goes off the edge of the screen, this function is going to get called. So if you look here in this update function, not only did I teleport him, but I also called a function that does nothing by default, but lets me change it in the bullet. So now if I want to, I can also make the player get destroyed if he goes off the edge of the screen. Or I could do something crazier. So if I take this function, went off edge of screen, and I implement it inside the player, let's do something a little different. Let's make the player grow in size every time it goes off the edge of the screen. So what I'm going to do is every time he goes off the edge of the screen, he's going to grow 50% bigger. And this is just to demonstrate the behavior that you don't have to destroy You don't have to destroy anything. You can do whatever you want to. And the key is that I have this function that I can write on my game objects now that changes the behavior. And every time I go off the edge of the screen, I'm going to get bigger. What's? It'll be okay.
I don't know, man.
It's still only when the middle of my ship goes off the edge of the screen, though, right?
Yeah. That's just point of origin.
Capital ship? My bullets are super tiny still. Oh, there's my bullet got destroyed. But does this make sense? Like, instead of writing code again, like this is the whole point of object-oriented programming, is writing as little code as possible, which is kind of a funny thing to say when you're a programmer and your job is to write code. A lot of it comes down to writing code when you need to. Capital ship?
Is it still getting big?
Yeah, it's going to keep getting bigger infinitely. And there might be a max scale internally. I might have reached it, yeah. I mean, other things we can do is take the same behavior. Maybe when I go off the top edge of the screen and the bottom, I'll get bigger, but the left and right, I'll get smaller instead. How would I add that behavior too? Well, if I take this function and I have a bool that gets passed to it that says, hey, off top of screen, and when I call the function now, I can pass true or false to it based on whether I went off the top of the screen or not. So in this case here, I'm going to pass false to this function now if I went off the left and right. But off the top and bottom, I can pass true. And by default, bullets are not going to care. They don't care if I go off the top edge of the screen or not. But I still need to add this parameter to all the other functions. So bullets don't care. It doesn't matter if they go off the top of the screen, they're just going to destroy themselves. But the player, depending on if I went off the top of the screen, I'm going to do this, like so. Otherwise, I can cut my scale in half. So if I go off the left side now, my ship gets tiny. Go off the top side, my ship can get tiny every time.
It's so small.
But that change in behavior is controlled by me. And what's the second part about this is that because everything's using the same behavior, I don't have to actually, I can change what I consider the edge of the screen. I can make the edge of the screen actually a lot smaller too. I can make it something like 300 off the edge. And 300 off the top. Maybe 150 off the top. So that I'm teleporting not off the edge of the screen, but somewhere like with a margin. And this will apply to everything, like not just the player. Wow. I got scaled up super tall. I want to make sure here I got left, position X. Ah, here, I missed one. So my bullets now get destroyed when they hit the edge of this invisible box here. And I'm teleporting even though I'm not on the edge of the screen. So if I were to have like an image or something like that, let's say a background image that had a border with like a score and like a header, I could actually wrap my screen around that and I could change my behavior and my game acts like my window is smaller, right? And all the code is shared right here. I write it once and everything uses the same stuff. And this principle is what we're going to use for collision detection. All right, let's get into that. Are we any questions on that before I jump in? So this is kind of like starting to show off some of the power of object-oriented programming, where you have differentiating behavior in your classes based on functions that you write. I'm going to actually get rid of the went off edge of screen behavior for this. Actually undo all this stuff that I just did. because I'm going to use this as a lecture. I don't really want my bullets to get destroyed when they go off the edge of the screen, so. But you guys can see now this function is literally one line of code, just destroy it. Okay. So let's talk collision detection. I want to review a little bit about what collision detection actually means in a game, because by default, a lot of games, like a lot of game edges, don't have any kind of collision detection built in. There's some that do. Like if you ever use a Box 2D, if you ever decide to make a physics-based game that has a rigid body collision detection built in. But for us, what we really want to do is we want to create the concept of something colliding with something else in the game. Specifically, our bullets colliding with an object. And the first step I want to show you guys is I want to make an object that is going to represent an asteroid in the game. And I'm just going to make one, and then I'm going to give you guys a lab as well. I have a lab here. And so this lab here is, there's 5 parts to it, and we're going to do the first part of collision detection first together, and then we're going to, I'm going to give you guys the homework, or the lab work. Okay. So the first thing is, I want to create a new type of class that represents our asteroid. So as you can see here, I have a bullet and a player. Well, my asteroid is going to have a sprite that goes with it too, and it's going to be a game object just like everything else is. So if I take my bullet class, I'm going to make a brand new class that's called asteroid. And I'm going to make this thing have a couple of arguments to it. One is going to be the texture that I want to use, and the second is going to be the position. Okay. It's just going to be a very straightforward class. It's going to be a game object, so it's going to have position, it's going to have velocity. I don't want it to have drag, so I'm just going to go ahead and write that function here from the bullet. But I just want to create one of these guys on screen, and I happen to have some images. Just happen to have some images prepared ahead of time. Yeah.
So you don't want apply drag, so you're putting the function in there so you can overwrite it?
That's correct. I actually just overwrote it here. See how it's empty?
So that is that's the constructor right there, and because there's nothing in it.
This is the constructor right here.
Oh, okay.
This is another function here.
Okay.
Apply drag is a function that says, hey, do something to slow down this object, which the bullet doesn't have and the asteroid won't have either. Only the player has.
So if it because it's if we weren't to put apply drag in there, because it's a game object, it would automatically put apply drag. So
That's right.
we put apply drag in there, but nothing in it to override what it's doing because it's going to
That's right.
replace it.
Yeah, we override it to do nothing. Literally says do nothing. This is just a comment. But yeah, I don't want it to do anything, just like what the bullet's doing here.
Okay.
Yeah, because all game objects have drag in our asteroids game. There's something you said where maybe not all game objects should have drag in asteroids, but that's how it is right now. Okay, so what I kind of want to do is I want to create one of these game objects, and I want to assign this sprite to it. And it's going to be a lot like the bullet and the player, where it's going to be a game object that I make with a constructor here. So I'm going to go ahead and take this constructor, and I'm going to implement it into the CPP. And when I'm done with this part, I'm going to share this in Zool so you guys can have it as well, so we can all start in the same spot. So here's my asteroid. Here's a constructor for my asteroid. And I need to call the parent's constructor too. You guys remember this, where this asteroid is a derived class from game object. It is a game object. However, I need to tell the game object about the texture and the position, just like the player does here. And the way you do that is by putting a colon after the constructor, and you can do this on the same line here, that calls the GameObject constructor. And the GameObject constructor requires two arguments. One is the texture path, and the other one is the position. I'm literally taking these arguments and I'm putting them here. Okay. And what I like to do is I like to put this on a new line, because it tends to be when you get a lot of arguments to the constructor, you want to kind of separate them out. So I have an asteroid which takes a texture path and a position. And I want to make one of these guys in my game now. So I go to my engine here. I have a player that I'm adding. I'm just going to call add object, adding my new asteroid. And my asteroid requires two arguments. Again, it's going to be a sprite. So it's going to be the sprite here. I think maybe this guy. Sprites PNG meteors. Meteoros. And I'm going to use this one here. And then the second argument is just going to be the position. So I'm just going to spawn it kind of near the top-ish, like so. And I'm adding a game object, and I'm creating a new asteroid right in the same line. I'm passing in the sprite that I want to show and the position. And I get something that looks like that. It doesn't do anything right now. It literally is just a sprite.
How does it decide what goes over and what goes under?
It's the order in which you add those objects. Like if I wanted that asteroid to be underneath the player, I would just add it first before I added the player. And that way the asteroid will get rendered first, and then the player, and then the bullets. Think of it like layers, sheets of paper that you're putting down. So let's take a look at this. So we kind of have to make a decision now of how we want to do our collision detection. And I happen to have done this enough where I understand what I need to do, but I kind of want to explain how we come to this conclusion. First of all, I'm going to change these to be white. Okay. So our game has a couple of shapes in it. And in order for collision detection to work in Pong, do you remember we had like a ball and we had a rectangle? Yeah. Right? And the way that we did the collision detection was actually detecting if this ball, which was actually more of a rectangle itself, was overlapping with that other rectangle. So like if I had a case like this, I could detect that this part was overlapping. Now that was collision with two rectangle objects. However, for asteroids, I kind of have a different set of shapes. So in this case here, what I actually want to do is I want to talk about collision as a circle. These two shapes in our game. It's going to simplify it a little bit. Imagine we had two circles in our game. And we needed to decide if those two circles overlapped one another. It's very easy to tell if two circles overlap one another on the board visually, right? You can know that these two things are overlapping. But what is the formula that you use to determine that these two things are overlapping? How do you know that given a position that is bigger, I have a circle with a radius of 10, in a position of, I have another circle over here, radius of 5, Those two things aren't overlapping, right? But how do you know that? How do you know that those two things are?
Distance from the radius. The radiuses are intersect. I mean, I don't know how to explain it.
Yeah. Well, this is a programming interview question, right? A simple, straightforward one. What if I drew these two radii lines kind of towards one another? Okay, does that help? How do you know that they don't intersect? What about if I knew what this was?
Distance between.
Yeah, what about the distance between those two circles? If I know that, let's say I know that the distance between this circle and this circle here, which I'm going to draw here, that distance from one circle to another is 20. Given that you know what the distance is between those two circles and you know the radii between those, can you guys tell me if there's a way to tell with a formula, given I have a circle X and a circle A and circle B? How I know whether those things are overlapping?
The distance between the two circles is 0, then they're overlapping.
If the distance between the two circles
Or-
does it have to be 0?
Less than 0.
Less than.
I mean,
Minus.
Well, what's the distance here? Like, okay, let's draw the same thing
Five.
with a circle here with radius 10. Circle here with radius 5. Distance between these two is going to be 13. So they're overlapping. Look at those numbers in relation to one another.
Over 2.
This distance of 13 is less than these two numbers together, right? This distance here, 20, is
5.
greater than these two numbers added together. So your formula is just, hey, if the distance between the two circles is less than
A plus
the
B.
radius, I'm going to radius 1, radius 2, radius 1 plus radius 2. That means that they're overlapping, right?
So take the x position of each and minus them and do the same for the y. And those will be your distance. And then you square them.
Square root.
Yeah.
You guys remember the distance formula? Yeah, the square root of this minus this. Distance. We actually did that in our code already. You guys remember this bit of code?
Is it that long decimal? Oh, no.
You see that where it says speed equals the square root? Speed is the distance of your velocity vector. So distance is that same exact formula. So distance here, my circle B, so the distance is less than r1 plus r2, where the distance is going to be equal to the square root of whatever this vector is, squared plus squared. This thing here, this vector that I want to get, that's the thing that we need to know. How do we get this line that I just drew from one circle to another? Okay. Let's talk about this a little bit more. If I have a coordinate system, how do I get this guy right here? How do I get this, that vector? I need another color. How do I get this line right here? Does anyone remember this from
Trig.
their trigonometry class?
They'll just do like, they'll just need the angle too. So
You don't need the angle.
Oh no, you have the two sides.
You just need to write it in length.
Subtract a from b.
If I want this vector c, c is going to be equal to a minus b. C is going to be represented by this vector minus the b vector. Let's make this a little simpler. Let me show you how that works. If a is equal to this and b is equal to this, what are the values of a and b? Let's say that I have a vector. This point is 0, 1, 2, 1, 2, 3, 4. A is equal to the vector of 2, 5. B is equal to the vector of 2, 0. Okay? I want the vector that goes up. So if I take A minus B, what is C equal to? Do you guys remember how to subtract two vectors? What is C equal to? 0, 5. What is that drawn on here? I get a 0 vector going up 5 units. All right? This is C. The reason why this is important is that if you want to know how to get a vector pointing from one thing to another, A and B here actually represent our circles. That's the position of where our circles are. Okay? So A on this grid is at 2, 5. That's where our one circle is. B on this grid is 2, 0. That's where our position, that's all a position is in our game. It's a coordinate of x and y. So if I want to get a vector from one to the other, I just subtract A from B, and that gives me C. What if I wanted to get a vector from this way down? What's that? What's that E from A? E from A. If I do C is equal to B minus A, that gives me a vector pointing downward, right? That would be negative 5 in this case here. So to get me a vector starting here, I'm going negative. So if you remember nothing else about vectors, remember that if I have two things here, two circles on screen, the asteroid and the ship, and I want to get the distance from here to here, first thing I need to do is get the vector that points from one to the other. If I want to get a vector that points from here to the ship, and I have a position of the asteroid, and this asteroid is A1, and this ship is S1, and those are my two position vectors, how do I get this vector C? What do I have to do to get this? We just did. Subtract A1 minus S1. That'll get me C. And that'll get me C pointing in this direction. This is super common. Like if I want to say, hey, get me the distance in a video game, in a 2D game, from me to some other point, like to the middle of the screen, the first thing is I need a vector from me to the middle of the screen. So you subtract the position of the middle of the screen by the position of the player. So in this case here, where I'm trying to figure out the distance between these two, this x squared plus y squared is actually going to be this C vector. And C, we know is going to be A x minus S squared plus A y minus X. How did I get that? Well, what is x squared in this case? It's C, which has, I'm not sure what those values are. C has an x and a y component to it. And the value of C that's what x is for C. So I take that and I plug it into here, and I replace this x squared with that value here. And I take this y squared and I replace it with the value here. Because remember, I have my vector for my asteroid here and my vector for the ship. And if I want to get those two values, I just subtract A1 by S1, and that actually is just the equation of AX minus x squared. So I can use that formula just like what I did here for my speed to figure out the distance. So let's write a little bit of code. I'm going to write some code here to demonstrate this stuff because I'm going to do it visually. It'll help a little bit. So the first thing I really want to do is I want to figure out the distance from me to the asteroid. And I'm just going to print that out to the screen. So I have my asteroid here. The first step to figure out whether two things are colliding is to get the distance between those two things, right? So I have my asteroid and I have my player. What I can do is I can do a cout. I'm going to print out to the console what the distance between those two things are. Okay? So first things first is I need to get the vector from me to the asteroid. From me to asteroid. Okay? That's what I'm going to do right here. Okay? And this is actually really straightforward. All you need to do is take the asteroid, get his position, which we don't have. I'm going to add this function right here. I'm going to take his position, and I'm going to subtract my position from it. This is going to be the vector from me to the asteroid. You can print that out too. I'm just going to print out these two numbers, the x value of the vector from me to the asteroid and the y value of vector from me to the asteroid. So I'm just subtracting the asteroid's position from my position, right? Okay. So can you guys see this? Let me make this a little bit bigger. Can you guys see those numbers? It says that the vector from me to the asteroid is minus 400, minus 200. It means that if I go left 400 pixels and up 200 pixels, that's what I'm going to get. That seems to make sense to me, right? Because where do we spawn our ship?
In the middle.
Like, do you remember the coordinates? I don't think I actually put those on here.
Key.
Yeah.
I thought when you go up, it's supposed to be a positive.
It's negative in this case.
Oh, it is.
Yeah. Because I'm moving up. Like, up is negative. Like, because the top of the screen is 0. Okay, so the player is getting spawned at 600, 300. And the asteroid is getting spawned at 200, 100. And the asteroid's at 200, 100.
Yep.
So if I want to get this vector that goes from here to here, I take this 200, 100, and subtract 600, 300, which is the position of the player. And what do I get? Negative 400, negative 200. That represents where he is. That's the first step, is getting that vector. So if I take this information, Vince, the only thing that's different is that when drawing coordinate systems for like normal math, like it goes like this, y 0 up down here, and like positive up here. So like this would be like 600 in y, but it's flipped for SFML. So like when I do this vector here, like this, it starts at 0 and then goes up, which is positive for normal like trig coordinate systems, but in SFML, the screen starts at the top right here, 0, and goes down.
Okay.
So it's flipped. That's why there's might be some confusion there.
So you're using the bottom right coordinate logic.
Well, in this case, in here, this is negative 600, which is not correct. The whole y is flipped in SFML. Okay, so we're printing out negative 400, negative 200, right? What if I move left? Which value will change? The x value, right? So I'm going to move, and the x value is getting closer and closer to 0 until I'm basically under it, and then it goes to 0. And the further away I get from it, those values are changing, right? So not only are the values changing in sign, but they're also changing in magnitude. The further I get away from it, the bigger those numbers get, right? So if I take that and I get the distance of that, so if I have negative 400, negative 200, what is the distance of that vector? Like, what is the hypotenuse of that triangle? I'll do this. I know that this is negative 400, right? I know that this is negative 200. What is this guy right here? What is the distance? What is the formula for that?
So you said it was a minus b.
Remember the Pythagorean theorem again?
A squared,
What's that?
or a squared plus b squared.
A squared plus b squared equals c squared, right? So if I take the calculator and do 400 times 400 plus 400 times 400 plus 200 times 200, and then take the square root of that, which is 447.21. That's going to be the distance between those two things. And now that I have the distance, remember, all I have to do is compare the distance against the radius of both those things, and then I'll be able to tell if they're overlapping or not. So let's calculate the distance now. What is the distance? Distance is equal to the square root of the vector from me to asteroid.x, x squared plus y squared This is going to be the distance. Okay, I'm just going to print that out as well. And let's just run this. So we should get 447, 214, which matches what I have up here. And that distance changes, right? So the closer I get to it, my distance goes smaller and smaller until I'm right on top of it. So if I look at my distance, if the radius of both me and the asteroid were 50, if you take that distance and you compare it to our formula, which is distance is less than the sum of the two radii, I would know that I'm colliding. If this number is less than 100, that means that I should be colliding, is essentially what our formula is. So if I see here, I'm not colliding because that value is still greater than 100. As soon as I get less than 100, or maybe let's make it 80, bam, I get a collision, right? So that's the logic that we're going to use to determine whether we're colliding with something. Okay? Questions on this so far? We have the distance, we have the vector. Now we just need to associate a radii with each of these. So in our game object now, what I'm going to do is I'm going to add something called a collision radius onto our game object. This is a property that I'm going to initialize in the constructor for the game object to be 0 by default. Nothing in our game is going to have a collision radius by default. And then inside of our asteroid, I'm going to set the collision radius equal to 50. And for the player, we can also set the collision radius. But the first thing I actually want to do is do a bullet, because our bullets are the things that are actually going to collide. Okay. So I'm going to set the collision radius of our bullets to be 20, just because that's kind of a reasonable size for how big I think our bullets are. Like so. And I'm going to take this idea and I'm going to basically make it work for any number of bullets. This is great and all for me showing you guys how to calculate the distance. However, this logic that I do right here actually needs to be done for every single bullet and every single asteroid. Right now, I'm figuring out the distance from me to a single asteroid. But what happens if I add like 5 asteroids? How do I do the same logic? How do I tell whether I'm colliding with all 5 asteroids or not? Let's just say I just go ahead and duplicate this. Or we'll just do a couple here. We'll do it twice. So I'm going to add 2 asteroids now. How would I detect if the player collided with either of these? Right? I have 2 of these. Right now I'm really close to that other one. However, the distance is only being compared against that first asteroid. Also remember that every time you break an asteroid, you're going to spawn more asteroids. So you can't really count on the fact that you'll know how many asteroids are around. You might have 30 asteroids around. You might only have 1. Either way, you need to do collision detection against all of them, right?
So would you make an array?
Yep. Thankfully, though, we already have an array. We have an array of game objects already. Do you remember this thing that we made here inside of our game.h? Look at this guy. That is an array of every single game object in our game. It contains our asteroids, it contains our bullets, it contains our ship. Everything that is in our game is inside this array. So this array represents anything that could potentially collide already. So that's what we're going to use to detect collision. The way that you do collision detection for us is we're going to do a nested loop. The way we're going to do this is, let's say we have, Excel, my favorite. This is going to represent our list of objects. Okay? We're going to have our player in there, right? We're going to have a couple of asteroids. These guys are maybe 5 of these. Every time the player shoots, he's also going to have a bullet. Remember, he can have a lot of bullets on screen, right? So this might be a sample size of what our array looks like. So how are we going to set it up so we detect collision against all of these? We actually have to test collision against each of these bullets against each of these asteroids. And in fact, eventually, we're going to have to detect collision from the player against the asteroids. And if we have UFOs, we're also going to have UFOs that shoot bullets at me that are only going to be testing collision against me. So the way we're going to do this is we're going to start off with very simple. We're going to assume that everything can blow up everything else. We're just going to assume that by default. And then we're going to say, okay, not everything dies when it overlaps. Okay? For instance, when asteroids overlap with one another, I want to know that they overlap, but I'm not going to do anything about it. Right? Because normally in asteroids, even though the asteroids themselves may float over each other, nothing happens. But to make our code simpler, I'm just going to assume that everything cares about overlapping with everything else, but the only things that blow each other up are asteroids against bullets, okay? Kind of like how the drag works, where we have the apply drag function only applying drag to the player. The asteroid and the bullet are the only things that are going to collide with one another. So here's what we're going to do. I'm going to add this concept of this guy here. He's going to be the first thing we're going to grab, and I'm going to take this guy and put him here. Okay? And then this guy is going to be the current thing that I'm going to be looking at to collide with. Collide test. So I'm going to take this player, and I'm going to see if he collides against the asteroid. Okay? So I'm going to take this player and the asteroid, and I'm going to compare them against one another. Okay? Are these two things colliding? Okay, maybe they are, maybe they're not. It doesn't matter, but I'm going to figure out whether they're colliding. Next thing is I'm going to compare these two things to see if they're colliding. Then I'm going to compare these two things. I'm going to grab this player and I'm going to go through the entire list to see if the player is colliding with anything in this list. Then I'm going to go to the asteroid. I'm going to grab this asteroid here. I'm going to put him here. And then I'm going to say, hey asteroid, are you colliding with a player? Are you colliding with this asteroid or this asteroid or this asteroid? I'm going to go through this entire list and I'm going to check collision against all of these. And I'm going to repeat all the way down to the bullets. So I'm going to say, hey bullet, are you colliding with this player, this asteroid, this one, this one, this one, this bullet? The bullets are actually going to test to see if they collide with other bullets too. Now, what we're going to end up happening is for every amount of objects that we have, every object is going to compare collision against every other object in the game. And the reason why this is expensive is if I ever have 1,000 bullets on screen, or however many bullets, you can imagine this list being very big. Every one of these bullets has to compare itself against every other bullet. And every asteroid has to compare against every other asteroid. That's right. Even if it doesn't care about the collision. Now, again, this is why I said we're doing this because it's for simplicity's sake. It's not for performance. Because as soon as you hit 1,000 objects, the amount of things is all 1,000 objects has to compare against every other object, which means you're doing 1 million comparisons every frame. Okay? Just to see if any of the objects overlap. It's an n squared problem, which means that the number of objects that you have squared is how many collision tests you have to do. Which is why if you have like 1,000 objects, it actually is not 1,000 collision tests, it's 1 million. And if you have 10,000 objects, which is that? 100 million? That's not even feasible. You can't even iterate that many times. There are a ton of other methods to do collision testing in a 2D game. This is just one of them. But it'll work fine. Like even 100 objects, it'll be able to go through 100 objects because it's only 10,000 iterations. It can actually do that really quickly. But any more than that, and you're kind of getting into bad territory. All right? But I'm just letting you know that this is the way that we're going to be writing our collision routine. Okay?
So just circle checking circle?
Yep. It's just going to be circle against circle. It's going to be very simple. So what we're going to do is I'm going to go into my game. And right here in update, right after we do an update, I'm going to do our collision test here. So what I'm going to do is I'm going to write a loop. And then I'm going to write another loop inside that other one. I'm going to nest these two guys together because I need to compare one game object against every other game object. So I'm going to say this one is the current, and this one is called the other. And these two loops inside one another is going to let me compare one object against every other object. So I need to call a function on this current object that compares it to another one. So here's what I'm going to do. Inside game object, I'm going to write a function called isCollidingWith that compares this object against some other object, which I'm going to write as a pointer to another game object. This colliding with function, I'm going to put into the CPP. And it's going to return true or false. It's going to return true if this object that I'm inside is colliding with the other object, with all the logic that we just talked about distance and radii. And so I go back to my game and I say, hey, current is colliding with other. And the only thing I'm going to do for now is I'm just going to do a cout. Found a collision. Okay? And that's all it's going to do. It's just going to print out when it found a collision. And all we have to do now is write this code. We have to write this code to compare these two objects against one another. All right? So what were the three pieces we needed? We needed the distance, we need the radius between of the first object, and we need the radius of the other object. So why don't we first get the distance? Well, we have all this code here. I'm just going to take it, and I'm going to put it here, and I'm kind of retrofit it. Vector, I'm going to call this one vector from me to other. And I'm going to get the position of the other guy, compare it to this position. That's going to be the vector from me to other. And the distance is going to be this. I'm going to add IO stream to this guy as well. So all this function is doing right now is just saying, hey, spit out the distance from me to other. There's one thing that we have to do though. If I go back to my spreadsheet, when I grab the player, I'm comparing the player against everything else, which means that I'm actually going to compare the player against himself too, which I want to exclude yourself from the collision test. I don't care if you're colliding with yourself, because you technically are going to be able to. And I'm going to say if this is not equal to other, is my test that I'm going to wrap around. This right here is kind of an interesting thing. This means, hey, this is me. Compared to the guy that you want me to compare a collision against, if we're the same person, then we're not going to go into this function. We have to be different people to do collision comparison. Okay? So let's run this. One other thing. I'm going to return true in this case, and return false if they didn't collide. Actually, I'm not going to return true at all yet, because we actually haven't done our collision testing. So let's just put a breakpoint inside our game. So I'm just going to run, it's going to hit this breakpoint right away. I want to show you guys the game objects. I have 3 game objects right now. I have 2 asteroids, and I have a player. The first thing it's going to grab, this guy's going to be an asteroid. It's going to be comparing this asteroid against something. The other guy is going to be the first element in this array, which happens to be the same exact asteroid. So I'm going to go inside this function that I called, is colliding with. This pointer and the other are exactly the same. I'm comparing the asteroid against itself. So it bails out, does nothing, and then continues on. The next thing is I'm going to grab the next object. So this is a different asteroid now. It's going to see if the 2 asteroids are colliding with one another. Now these 2 are different, so now I get to go into this function. It's going to spit out the distance between the 2 asteroids, which is 200 pixels apart. Which, remember back to our engine where I created those 2 asteroids. This one is at 200, 100 and 400, 100. These 2 asteroids are 200 apart. Cool. Next thing it's going to do, it's going to compare the first asteroid against the player. And it's going to spit out how far the player is from the first asteroid. The first asteroid is at 200, 100, so it should be 447, I think we said it was. Right? Cool. That's the distance from the player to the first asteroid. Now we're done with that first asteroid. Now we're going to restart. We're going to grab the second asteroid now, and we're going to restart this whole process again. We're going to compare the distance from the second asteroid to the first asteroid again. See if they're colliding with one another. They're still going to be 200 pixels away. However, the vector from me to the other guy is now minus 200. It's the second asteroid compared to the first asteroid, right? And this thing continues on and on and on. So I'm just going to let it run. And it's going to show that I'm calculating the distance between every object to every other object. It's doing 9 comparisons right now, even though I only have 3 objects. So what we're going to do is, I'm going to get rid of this cout, and we're going to add our behavior here. Now that we have our distance, we now remember our formula. If the distance is less than the radius of the first one plus the radius of the second one, right? The radius of the first guy is just going to be my collision radius plus the other collision radius. That's it. If these are less than, I'm going to return true, and it's going to mean I had a collision. So now I have my bullet And every time I shoot, it's saying it found a collision. Why is it saying that I have a collision every time I fire a bullet?
It's colliding with the ship.
It's colliding with the ship. Yeah, every bullet is actually colliding with the ship. That's actually okay. Remember, that's expected. In our game, the way we're doing collision, everything is technically going to collide with everything else, even though I don't want to do anything about it. Okay. So here's how we resolve this. What do we actually want to do when we detect a collision? Well, it depends on what you're colliding against. So we're going to write one more function. I'm going to talk about a brand new concept in object-oriented programming, which is figuring out what kind of thing you're colliding with. So I'm going to add a virtual function here because this function is going to change based on what class overrides it. I'm going to call it collided with. And this function is going to get called anytime an object is actually colliding with something else. And by default, I'm going to leave it empty. So I'm going to put these little curly braces here with empty, meaning that the default game object doesn't care about collision. However, for my bullet, I'm going to write an implementation here. I'm going to go to my bullet. I'm going to write this function. I'm going to override it. Now that I've overridden it, I can do something. What I want the bullet to do is, if it collides with something, I want to destroy the bullet, and I want to destroy the thing it collided with. So in this case, if it collided with something, I just want to destroy the bullet, and I want to tell the other guy, hey, you're also destroyed. But remember, our bullet was colliding with a player by default. If I do this and I fire a bullet, what's actually going to happen is that the player is going to get destroyed right away. Because technically the bullet collides with everything. We just don't want it to destroy everything. One more piece that we're missing here is that once we have this function, we actually need to, instead of doing a cout find a collision, we need to say, hey, current collided with other. We're going to call this function telling the object that it collided with something else. Okay? So how do we tell whether we collided with an asteroid or we collided with a player? So let's just put a breakpoint here. Remember what I said. The first time I fire a bullet, it's going to hit this because it's going to collide with a player. Cool. Well, the problem is that this other guy, you can tell, if I pin this thing, can you guys tell what that is from the little object? See where it says player right there? That's a pointer to a player. That means that this is a player object. And this means that it's the bullet collided with the player. That means that I'm actually going to destroy the other player right now. So if I run right now, the player disappeared.
Yeah, that's what I was saying.
So I shoot, and the player disappears because the bullet blew himself up. Well, that's kind of neat. I was able to blow the player up, but I only really want to do this with an asteroid.
So it ignores the first collision that it makes?
You could do that. You get into kind of a weird case where if a bullet goes off the edge of the screen and hits yourself, you'll kill yourself too.
Or it just ignores the player?
Right, that's what we want to do. We want to just ignore the player. Well, specifically, we only care about asteroids. So, how do we tell if this thing is an asteroid or not? Remember, this is a pointer to a game object. The way that C++ works, you can store an asteroid in here. This could be a player. This could be a bullet as well. How do you detect whether it's an asteroid or not? So, there's a lot of ways. I'm going to show you guys the way in C++ that's kind of like the way that I think you guys should use in your games. And we don't actually use this method in Overwatch. It tends to be a little more expensive to have this feature enabled, but we do basically the same thing. We're going to see if this object is an asteroid. And the way that we do that is we're going to grab a pointer to an asteroid, and we're going to set it equal to other. And unfortunately, this doesn't work by default. What I really want to know is if this other is equal to an asteroid, I want this thing to be filled in. There is a feature in C++ called a dynamic cast. And a dynamic cast will go ahead and take this object and try to turn it into an asteroid. And if it is an asteroid, it'll succeed. Otherwise, it'll fail and return null. So that's what we're going to do. We're going to call something called a dynamic cast. It takes an argument of the pointer to the thing you're casting it to, plus it requires you to tell it what you want to turn this object into. And you tell it what object to turn it into inside a series of angled brackets, and we're going to turn it into an asteroid pointer. So we're going to take this other guy, try to fit it into an asteroid. And if it succeeds, this thing will be a non-null pointer, which means I can write an if statement in here. So watch what happens now. This function is still going to get called. So I'm going to shoot. Still going to get called now. And the other thing is still a player. However, I'm going to try to turn this player into an asteroid. But remember the way our hierarchy is, it only works if your hierarchy matches. So here's my game object. Here are my things that derive off game object. I have bullets, right? I have a player, and I have an asteroid. The way that dynamic cast works, it only lets you convert something if that object is actually a child of the thing you're converting from. So I have a game object, right? And it's going to try to turn this player into an asteroid, which you can't. Even though they both have the same parent, these two things are not relatable. It'd be like trying to turn a car into a motorcycle. Instead, what we're going to try to do is convert this thing into an asteroid, and if it succeeds, that means that my thing is actually an asteroid. Otherwise, it'll fail because it means that it's something else. So here's my other guy. It's a player. I'm going to do my dynamic cast, and look what it returned here. Returned null, all zeros here. That means that it did not successfully cast it, which is perfect because we don't want it to collide with the player. So what I want to do now is I want to aim at the asteroid, and I'm going to put a breakpoint here. It's going to hit it one time when I fire. I'm going to continue. It's going to hit it again. Maybe I fired multiple times here. I'm actually going to put a breakpoint right here. So now what happened? So look at my other variable now. My other variable is now an asteroid. It's an asteroid now. So when I cast it, I actually get an asteroid back. This thing succeeded, which means it's not null, which means now I can successfully destroy the asteroid and the bullet. So I'm going to fire again. Boom. Thing went away.
So how expensive is the dynamic casting?
It's pretty cheap. However, if you do it a lot, it gets to be kind of expensive. You'll never see this show up as a performance problem for 2D games, really. However, for something that you want to run on low hardware, you don't want to be doing this. Because this makes it, when you enable this feature to be able to be used, it starts injecting all this data inside all of your objects to determine whether this thing is considered an asteroid or not. It's called reflection data. So in a lot of cases, you don't need that data. You can implement this only for things that you care about. So that's what we do on Overwatch. We basically have this feature, but only for certain sets of things. Most objects in Overwatch, we don't care whether they're an asteroid or not, or whatever comparison. A few things we do, however.
Cool.
All right. So this is our collision. This is how our collision is working in our game. You specify a collision radius for the thing you care about, for both things. And then you implement this function collided with when you want it to do something. Okay? And this is what you do to destroy. One other little piece, one thing we can do to make it a little bit more efficient is inside here, inside our is colliding with function, where we're comparing this, we can also say, hey, if is destroyed, we want to make sure that we're not dead and the other thing is also not dead yet. This will make it a little bit faster for us too, because this will make us skip things that are already dead. Okay, that's the last piece I'm going to give you, and then what I'm going to do is go over to lab real quick, and then I'll give you guys all this lab file so you guys can grab it, and I'll give you the solution too. I'll put this up on Zool. Okay. Let's go to lab real quick, and I'll give you guys a break, and you guys can come back and do the lab, all right? So the first part of the lab is I want you to spawn 5 asteroids randomly around the screen, okay? And then I want you to spawn 5 asteroids, and half of them should use the small texture, and half of them should use the large texture, okay? Then I want you to have them start moving in random directions when they spawn. Okay? And then number 5 and 6, or number 5 we're going to do together. There's one more piece that I want to do with you, which is I'm going to show you how to take an asteroid, and when it breaks, it's going to create smaller asteroids. And then number 6 is I want you to make all the asteroids rotate on the screen. Okay? So take a break, come back, and we'll do number 1 and number 2. And then we'll do number 4 together, okay? Or number 5 together, yeah.